All right, this is section 2.4, and we're talking about complex numbers. Okay, expressing square roots of negative numbers as multiples of I. So we know to find the square root of any positive real number. In a similar way, we can find the square root of any negative number. The difference is that the root is not real. So if the value of the radicand is negative, so what's inside the square root? What's inside the square root is negative. The root is said to be an imaginary number. So if we look at the square root of -1 right here, that's going to be I. Now how we get from this line to this line, if I square both sides, so if I take I is equal to the square root of -1 and I square both sides, these will cancel and I have I squared is equal to -1. That's how we are getting this right here. Okay, so these two items right here, they're going to be key for this section. Okay, evaluate the expression square root of -49. Okay, well, if we just looked at the square root of 49, we know that to be 7. But since I have that negative in front of it, it's like I have the square root of -1 times 49. So we can break that up into the square root of -1 times the square root of 49. Now we just learned that the square root of -1 is going to be I, and the square root of 49 is 7. So our answer is 7I. Okay, now evaluate the expression of square root of -40. So let's look at the square root of 40. We could write that as 4 times 10. So that's going to be the square root of 4 times the square root of 10, which is 2 square root of 10. Okay, now let's look at -40. So this is -1 times 40. So -1 times the square root of 40. We know the first one to be I. And we just found that the square root of 40 is, so times 2 square root of 10. Now the technical way of writing this is 2I square root of 10. And that's your final answer. Okay, so imaginary and complex numbers. So a complex number is the sum of a real number and an imaginary number. It looks like A plus BI. So this first part here is the real part, and the second part here, the one attached to the I, that's the imaginary part. Imaginary numbers differ from real numbers in that the square imaginary number produces a negative real number. When a positive real number is squared, the result is a positive real number. When a negative number is squared, the result is a positive real number. Okay, so a complex number is a number of the form, I just wrote that, A plus BI. This is called standard form, where A is the real part of the complex number and B is the imaginary part of the complex number. Now, if B is equal to 0, then A plus BI is a real number because A plus 0 times I, well, 0 times anything will make it go away, and I just have A, which is the real part, so we would just have a real number. Now, if A is 0 and B is not 0, the complex number is called a pure imaginary number. So it would look something like, so A plus BI. If A is 0, we would have 0 plus BI, which that would just be BI. So an example would be 5I. That would be a pure imaginary number. An imaginary number is an even root of a negative number. Okay, even root of a negative number. So the square root of negative, say, 2. This would be I square root of 2. Okay, so let's look at this. Evaluate the expression cube root of -8. Now notice we don't have an even root, we have a cube root. Over here it said an imaginary number is an even root of a negative number. Here we have an odd root of a negative number, so it's not going to be imaginary. So what we need to figure out is what number times itself 3 times will give us -8. Well, if we do -2 times -2 times -2. So negative times a negative, positive. Positive times a negative, that's a negative. 2 times 2 is 4. 4 times 2 is 8. Okay, so our answer, and I should have written it, should be -2. So notice that this is not an imaginary number, this is an actual number. And so because we have an odd root instead of an even root. Okay, now identify the real and the imaginary part. So we need this to be in A plus BI format, which it's not. So I need to take this 2 on the bottom and distribute to the first and to the second term. So 4 divided by 2 minus 12i divided by 2. So this will be 2 minus 6i. So the real part is 2 and the imaginary part is -6. So A is equal to 2, whereas B is equal to -6. Okay, express the square root of -24 in standard form. Now back here it said that standard form is A plus BI. Okay, so I'm going to go ahead and pull that negative out, which means put an I in front. So now I'm looking at square root of 24. I can write that as 4 times 6. Break that up into the square root of 4 times the square root of 6. So that will give me I times 2 times the square root of 6. So this will be 2i square root of 6. Now express this in standard form. Well, a plus bi, all we have is the bi part. So we could say 0 plus 2i square root of 6, and this would be standard form. Okay. Okay, plotting a complex number on the complex plane. Now what used to be the y-axis is now called the imaginary axis, and what used to be called the x-axis is now called the real axis. Okay, and your ordered pairs will be described as A, or the real part, comma, B, or the imaginary part. So if we're going to plot the complex number -3 plus 4i, well then really, if we're plotting A, comma, B, that's going to be -3, comma, 4. Okay, so the real part is -3. So 1, 2, 3. And then the imaginary part is 4. 1, 2, 3, 4. So here's our point right there. And that's it. Okay, plot the number for -i. So the real part is 4 and the negative or the imaginary part is -1. So real part we need to go 1, 2, 3, 4 and the imaginary part we need to go down -1. So our point is right there. That's it. Okay, now let's look at adding and subtracting complex numbers. So what you need to do is combine the real parts with each other and then combine the imaginary parts to each other. So if we look at A plus BI is one imaginary number, plus C plus DI is another imaginary number. And notice A and C are the real parts, B and D are the imaginary parts because they're right by the I. Notice over here I have a plus c, the real parts, added together, b plus d, the imaginary parts, added together, and then I have an I tagged on the outside there. The only difference is subtraction. So here you would have the real parts subtracted and the imaginary parts subtracted from each other. So let's look at this one. Perform the indicated operations and simplify. So here we're adding two complex numbers. So what we need to do is negative 2 minus 4i plus 1 plus 6i. So I'm going to combine the negative 2 and the 1 to get negative 1. And then I'm going to combine the negative 4i and the positive 6i. So 6 minus 4, that's going to give us plus 2i. And that's our final answer. So it's really like combining like terms. Okay, now let's look at this one right here. So now we have two complex numbers subtracted from one another. This is where you need to be careful because what we're going to do is distribute this negative to the 3 and to this negative 2i. So we'll have 2 minus 3i minus 3 plus 2i, because the negative times the negative will give us a positive. Then we're going to combine the 2 and the negative 3. That will give me negative 1. Then I'll combine the negative 3i and the positive 2i. So that will give me negative 1i, which we don't ever see a 1 in front of the I. It's already assumed. So negative 1 minus I will be our final answer. Okay, now let's look at this one. Perform the indicated operations and simplify. 5 plus the square root of negative 36 minus 3 minus the square root of negative 4. Okay, so we can look at this 5 plus the square root of negative 36, and we'll go ahead and distribute this negative. So minus 3 plus the square root of negative 4. Now because we have even roots, both with the square root of negative 36 and the square root of negative 4, these are going to be imaginary numbers. So 5, and this is going to be plus, I'm going to take an I out for the negative, I square root of 36 minus 3 plus, I'm going to take an I out for that square root of 4, and then I plus square root of 36 is just 6, so this is 6i minus 3 plus, and then the square root of 4 is just 2, so plus 2i. So then I'm going to combine the 5 and the negative 3 to give us 2, and then combine the positive 6i with the positive 2i, and that will give us positive 8i, and that will be our final answer. Now let's look at multiplying complex numbers. Okay, so we'll look at two things. Multiplying a complex number by a real number, which we'll just use the distributive property and then simplify, and then multiplying complex numbers together. You can use the distributive property or you can use a full method. Just remember that that I squared is the same thing as negative 1, and we'll do the same thing as what we were doing with addition and subtraction. We'll group the real terms together and we'll group the imaginary terms together. So first off, let's look at the first case, multiplying a complex number by a real number. So 1/5 times 5 minus 2i. So all we need to do is to distribute this 1/5 to the 5 and to the negative 2. So 1/5 times 5 minus 1/5 times times 2i. So 1/5 of 5, that's like 5 over 5, so that's 1 because it'll cancel out, minus 2i over 5. And you could write it as 1 minus 2 over 5 times I. And that's it. Now let's look at the second case where you're multiplying two complex numbers together. So I'm just going to use the distributive property. So I'm going to first take this 3 and distribute to this 2 and to this 3i. Then I'm going to take this negative 4i and distribute